right, so now let's take an example that kind of shows you this idea. We've got the sine of 4 times x minus pi over 3. Notice the argument is factored. Okay, that's going to be a key part of any of these problems, is to make sure that argument is factored. If it is factored, I have a general formula up here. In that factored form, we've just seen that the period is 2 pi over b being the constant being factored out. Again, the x has to have a 1 coefficient. It has to be just an x in the parentheses. And the phase shift is the d value, the number being subtracted. Okay, so here, I want to try and plot the graph of this. I need my 5 key points. I need to know my period, my phase shift, all that stuff. Well, the first thing I'm going to do is look for the period and the phase shift. The period is 2 pi over the b value, which is this multiplier on the outside there, the 4. Well, 2 pi over 4 reduces down to pi over 2, so that's our period. Okay, so it's a shorter period, half a pi period. The pi over 3 gives us our phase shift. Okay, so we're going to start at pi over 3. We're going to move half a pi over, and that will give us a full period. Okay, now I need to find all of my other 5 key points, the other 3 of the 5 key points. These are the, actually I need to find 4 of them, because pi over 3 is the first one. The period tells me how far to the last one. I still need the ones in between. Okay, my recommendation on this is to take the period, cut it into fourths, cut it into quarters, and just add that number to the phase shift. Okay, so add it to the first point. So if you imagine a number line here where you start at the phase shift, start there, and then you add a quarter of the period, and you do that 4 times, you'll get the other 4 key points. Okay, so 1, 2, 3, 4. This would be, you add 1/4 of the period. That's probably too small. You're probably not even able to really read that. There. So you add to that 1/4 of the period, and then you do that again, and then you do that again, and then you do that again, and then overall you will have 1 period. So you add a quarter of the period 4 times. Okay. Well, to find a quarter of the period, you take 1/4 times the period, which is pi over 2, and you get pi over 8. Okay, so pi over 8 is this distance that you're going to add on. Then you start at the phase shift and add that number 4 times to get your 4 other points. So I get pi over 3. I'm going to add to that pi over 8. Of course, my LCD is 24. It would be actually very convenient to just do everything in terms of a denominator of 24 and then reduce as we go. So that's what I'm going to do. Let's create a denominator of 24. I've got to multiply by 8 and 8 and 3 and 3. This will become 8 pi over 24 and 3 pi over 24. And when I put them together, I get 11 pi over 24. Oops. So this will be 11 pi over 24. That's the first quarter, I suppose. Then you take 11 pi over 24 and you add another pi over 8. But the pi over 8 is really 3 pi over 24. So that's what I'm actually going to add on, just to keep all my denominators already the same. So I take 11 pi over 24 and I add to that 3 pi over 24, or again equivalently pi over 8, and that will give me 14 pi over 24. Okay. Now 14 pi over 24 reduces to 7 pi over 12, right? Cut them both in half. So it'll be 7 pi over 12. That will be my middle point. Then I take that number and add another pi over 8, but remember I'm going to deal with the 24th, so I'm going to deal with the denominators that are like. So I'm going to go to the unreduced form, 14 pi over 24, and add pi over 8, which I know is already 3 pi over 24. And that's going to give me 17, sorry I almost said 7, 17 pi over 24. That doesn't reduce, so that's going to be my third quarter, 17 pi over 24. And then the last one is found by adding to this another 3 pi over 24. So we take 17 pi over 24, add another 3 pi over 24. Of course, that's going to give me what, 20 pi over 24? And 20 over 24, that does reduce. Divided both by 4, you get 5/6, right? So it's 5 pi over 6. And that's going to be my endpoint, 5 pi over 6. Now, I always like to do just a quick check to make sure that this total distance is 1 period. Make sure I didn't add anything wrong or reduce anything wrong. So I'm going to check and make sure it's 1 period. To do that, I'm going to subtract the right end minus the left end, just as a check. So I'm going to take 5 pi over 6 minus pi over 3. I need a common denominator of 6. You do a lot of fraction arithmetic here, I think, in a lot of these sections. Okay, so this becomes 5 pi over 6 minus 2 pi over 6. And when I subtract those, 5 minus 2 is 3. So that's 3 pi over 6. And 3 pi over 6 reduces to pi over 2 when you divide both top and bottom by 3. Well, does pi over 2 match the period I had before? It sure does. Okay, so that worked out. That should work out. And so now I have my 5 key points. When I plot my graph now, I want to make sure that my 5 key points are scaled properly on the x-axis. Okay, so the 5 key points here need to be scaled correctly. I don't want like a really big gap between the y-axis and the first point, and then a really small gap to the last point, and they're not consistent. Or I don't want a really small gap and then a really big gap. I want to make sure that the gaps are consistent with the actual way that they would be numbered on an axis, or where those numbers actually lie. It's not an easy task, okay? As I look at this, I think about cutting up a pie, 1 pi, into pieces, okay? A pie length, not a circular disc pie, but a length of pie, into pieces. And I could go with thirds or 24ths or sixths or 12ths. As I look at this, I think it's going to be easiest to split this into 12ths. Okay, I can get into 12ths because I can mark off 12 parts, 12 tick marks on a number line easier than I could do 24. 24 is going to be hard to do. And the thirds and the sixths, if I were to split it up into thirds, I'm going to miss too many things. If I split it up into sixths, I'm going to miss too many things. I think the 12ths would be the best. Now, each of these is going to be a little bit different. I'm just kind of thinking it through and trying to anticipate where the points are going to land. So let's try it out. If it doesn't work, we can always redo it with a different combination there. So I'm going to split up into 12ths. So I'm going to put 1 pi. I know all these numbers are less than 1 pi, right? 5/6 is just less than a pi. You'd have to go another sixth out to get to pi. So pi is kind of like, in this case, the farthest out I would need. Technically, I don't even need to go that far. I need 5/6 of pi, which is a little less. And And then I'm going to split this into 12 pieces. Now that's not an easy task, but as I'm looking at this, I'm going to just start cutting in half. 12 is an even number, so if I cut that in half, that gives me 2 pieces. Cut each of those in half, and I kind of know what those tick marks are going to be. You know, you got 1 pie, you got half a pie, quarter pie, 3/4 pie. Now I have 4 pieces, and if I cut each of those 4 pieces into thirds, I'll have 12 pieces, right? So I'm going to cut each of these into thirds, and that I can do roughly. I mean, it's not going to be exact, but that's not bad. That gives me 12 little markings, okay? Each of those then is 1/12. So I could start here, this is pi over 12. Then 2 pi over 12 would be pi over 6, same thing. Then we get 3 pi over 12, which is pi over 4. So I'm reducing these fractions as I go. 1, 2, 3, then we got 4 pi over 12. 4 pi over 12 reduces to pi over 3. Well, I already know that that's my first endpoint, so I'm going to just for my own reference, I'm going to put a star there. I want to make sure I keep pi over 3 in mind. So that's 1, 2, 3, 4. Then I get 5 pi over 12. 6 pi over 12 is the same as pi over 2. That reduces. Then we get 7 pi over 12. 8 pi over 12 reduces to, 8 over 12 is what, 2/3? So it'd be 2 pi over 3. So 9 pi over 12 is 3/4. Then we get 10 pi over 12, which is equivalent to 5 pi over 6. Well, that's one that I need. That's my endpoint, 5 pi over 6. And then I get, let's see, that's 10 pi. Then I get 11 pi over 12. And then pi itself is 12 pi over 12. So that gives me each of my 12s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 12. And then we reduce all the fractions. So it works out. I got my first point, I got my last point. My middle point is the 7 pi over 12, so that's on there, right there. And I also have, let's see, now 11 pi over 24 and 17 pi over 24 don't actually show up on the graph right now. I'd have to add those in, which is okay. Let me go through and get the middle and last points. Now remember, the sine wave it starts at the axis, goes up, then down, then back up again. So my intercepts are going to be the first point, the last point, and this middle point. Those are my 3 x-intercepts. Then remember, this graph has an amplitude of 1, keeping this simple. So I put a 1 and a -1 on the y-axis. Okay, I don't need my stars there, I've got those marked. Then my halfway point. Well, halfway between the first 2 will be 11 pi over 24. I'm going to put that mark. It ends up being halfway between 5 pi over 12 and pi over 2 as well. And so from there, I'm going to go up to 1, put a dot, and then that point, because I don't really have room to label it on my axis here, I'm going to go ahead and put the ordered pair in. It would be 11 pi over 24, comma, 1. Okay, that's my ordered pair. Then I do the same sort of thing over here to the right. I take halfway between the midpoint and the right end will be 17 pi over 24, and I drop that down to -1. And I'll put my ordered pair on that as well. That would be 17 pi over 24, comma, -1. Okay, now I've got my 5 key points. I then just plot the graph as a curve through them. And there we go. There's one period of the graph. As I said on some previous examples, if you needed to graph more than one period, you would just then add another, it was pi over 8 to each of these ends, add to the right or subtract from the left to get other key points, okay? Either other max mins or x-intercepts. But yeah, that gives you a pretty good idea of what that graph will look like. Now, I gave you an example that's pretty difficult here. I don't anticipate most of these to have as difficult of arithmetic. In fact, now that I gave you a hard one, maybe in the next example we'll scale it back a touch and make these fractions and some of these points work out a little bit nicer on the arithmetic side.